Good evening, students. I hope I'm audible to all of you. Let me open the chat as well. Yes, okay. Thank you for confirming. We will be starting the session in the next 6 minutes. Okay. Meanwhile, you can inform the other students to join in the session as well. Yeah, very good evening, students. I can read your messages in the chat. Some of you are asking about FSP platform, that is Future Skills Platform. Let me start the recording as well. Yes. Some of you, you are asking about the FSP platform, that is Future Skills Prime. See, remember one thing. There is no compulsion of completing courses from FSP. Okay. You can explore. It is free to explore and you will be getting an extra certificate from FSP as well. Right? But to get the internship certificate, it is important to get yourself registered with your AICTE ID in the FSP platform. Otherwise, we do not have any compulsory courses in FSP. Is that clear, everybody? registering on the FSP platform with your AICTE registered email ID is mandatory, right? That is also one of the eligibility criteria for the final internship certificate, right? Number one. Number two, unlike the LMS, for LMS, we do have mandatory courses to complete. That is, earlier it was intermediate and advanced, but now we have reduced it to advanced only. Those who have raised this concern in the LMS, we have already responded you. For the May batch students also, we have made only the advanced courses as compulsory. But if you say, ma'am, I would like to explore intermediate and basic courses as well, you are free to do that. Okay, but it is mandatory to complete all the courses under advanced. It is not just AI fluency, it is not just the other courses in advanced, but all the courses in advanced, completing them is compulsory. Okay, right? And this is about FSP and LMS. Okay, so if you ask me for the courses need to be completed in FSP, we don't have answer for that. It is your choice because we left it to you. You can decide. You can prefer your own set of courses to be completed from FSP. Okay, I think I've made it very clear. Second thing, some of you are asking for the eligibility criteria for the final internship certificate. Okay, so it is not just the course completion, but also your attendance and project submission is also equally important. There are three things. One is your attendance. Two, registering and completing courses from all the mentioned platforms, LMS, Microsoft Learn, and Future Skills Prime as well. So completing the courses and registering yourself with the AICTE ID in all three platforms is important. Third is your project submission. So today, maybe after the session in your Telegram group, we will be sending you the template as well, the project template. Those who have attended the AMA session now have a clear-cut idea of what to be done for the project. You will get the template as well in your Telegram group. So stay tuned in your Telegram group today because we are going to share the project template in there. Is that clear, all of you? If it is clear, you can send clear in the chat. Already I have mentioned recordings for AMA sessions cannot be given. AMA session has to be attended live. I have already said this in our Friday session as well. I mean, Thursday session as well. A lot of you have appeared for the second AMA session. That is good. Those who have missed the AMA session, there is one AMA session this week also. Do attend that. Okay, the links and everything, we'll be sending multiple different reminders in a Telegram group itself. So the third AMA is going to happen on 30th of May. That is this week, Friday. Okay, so do attend that. AMA session recordings cannot be given. You have to attend that live. Okay. So many of you have sent me clear. Good. Okay, so these are different things that you need to know. Today, we will be sharing the project template in your Telegram group itself. Okay. So after that, a couple of students have raised this concern in your LMS query section. Ma'am, I'm unable to change the MS username. Okay, so for regarding that question, we are in discussion with the technical team. We will keep you posted in the LMS itself. Okay, for that. And if there are any students attending from the April batch, please remember, if you are from the April batch, you should complete your internship within the April batch only. You should not continue pursuing your internship in May also. Even if you attend, you won't get anything from here, be it the certificate or anything. By default, we will remove your email IDs under duplicates. So please ensure that you are completing your internship in April only. If you are from April batch means. If you are from May, we still have time. Because for the final internship certificate, you need to get the eligibility criteria first. First thing is course completion and registering into all three different platforms. 2 is your attendance. 3 is your project submission. So still we have time. And some of you, you keep on raising questions in the LMS. Ma'am, where is my certificate for advanced, for intermediate? See, remember one thing. For advanced and intermediate or basic, we do not provide any separate certificate for them. There is no separate certificate for those courses. Some of you are sending a screenshot saying, ma'am, it is saying that I will receive my certificate in 5 days or 6 days. It is not like that. Right? You will get to see an achievement page, and we tell you to take a screenshot of that. So that is the proof of your course completion. So certificate is one, only one. That will be issued after meeting all these criteria. Okay, and some of you are asking, ma'am, will Microsoft logo be there and all that? Yes, it will be there. Okay, there will be only one certificate from the LMS. There is no separate certificates for your intermediate, basic, no, nothing like that. Is that clear, everybody? All of you? Please do not raise such questions. There is only one certificate that will be given after your internship. Okay. So if you want the course completion proof, you can take a screenshot of that achievement page. You can use that. Okay. So probably whoever have submitted your queries on the LMS must have your reply on the LMS itself. Please do check that. I guess I have answered pretty much of all your questions. Now I think I can hand over the session to the technical trainer. Thank you. Over to you, sir.
Very good evening, students. Is my voice clear? Am I audible?
Yes, sir, you're clear.
Yep. Okay. So we're gonna continue the project part. We'll just start with where exactly we had left in the last session. Okay. So before that, let me just share the screen. Yes. I believe my screen is visible. Yep. Okay. So we had started with machine learning, and we also had completed one of the project that is linear regression. And also we had worked on generative AI as well, right? Yes. So as we have completed one of the problem statement to regression, we'll land into one more problem statement, that is classification. So we're gonna just start with few basic theoretical concept, and we'll just land into the practical implementation as well. Just to take a quick recap, let me just start with machine learning. So machine learning, this is a landscape of the machine learning, like what we had started. So the entire branch computer science, and inside that there's a technology that is artificial intelligence, and within artificial intelligence there is a sub concept that is machine learning. And now you can see that how machine learning is being classified out here, right? So we had supervised learning, unsupervised learning, reinforcement learning, and altogether how exactly deep learning is being formed, right? So this was the flow of machine learning. One is defining the problem statement, then second one is like collecting the data, then developing a machine learning model, then testing it, like how your model is working. Then once your model is done, you can deploy or you can publish your project. Then finally you can just give the access, so you can manage your project part. These were few case studies what we had discussed in machine learning. That was one of the crop recommendation, COVID-19, sale forecasting, and fraud detection. Then we talked about types of machine learning, that is supervised, unsupervised, and reinforcement learning, right? And we had a understanding about supervised learning. So in supervised learning, we mainly target with the labels data, right? So whatever the data we collect, there will be label column. That is what we are trying to predict. So in simple terms, what you can just tell that supervised learning is nothing but you will be having some sort of idea what exactly you're trying to predict. That becomes your supervised learning. Then we had unsupervised learning. Unsupervised learning deals with unlabeled data. There will be no labels. You'll not be having any sort of idea what exactly you need to predict. Then when it comes to reinforcement learning, your model will learn the behavior based on the environment. So whatever the environment will be there, based on that, your model will start adapting to those things and it will start learning the behavior of that. Then we talked about the types in supervised learning. One was regression and classification. Regression means whenever we come across predicting some numbers, continuous values, that in that case we use regression problem statement, right? So when it comes to classification, we are classifying between two or more different things. So let us take a clarity again of predicting the temperature value, that becomes the regression problem statement. If we talk about classification for the same problem, like how can we do that? We can just tell whether uh, the temperature is like, not the temperature, like weather condition, whether it is hot or a cold, right? And let us take some other problem statement, predicting the house price. If we are predicting the house price, that means we are predicting what is the value of the house, right? So the value of the house will be given in the continuous value, the numbers, right? That is nothing but regression. And when we talk about classification, we can try to predict whether the house what we have taken out, whether it is expensive or it is affordable, right? So that is nothing but regression and classification. These were the few algorithms in regression, classification, and clustering. So in regression, we have linear regression, multiple linear regression, which we have already seen, right? And we have ridge regression, lasso regression, decision tree regression, etc. In classification, we have logistic regression, naive Bayes, KNN, decision tree, support vector machine. And clustering algorithms, we mainly target with k-means, dbscan, or hierarchical clustering. Okay, so basically in linear regression, uh, I had given a simple scenario that we are trying to predict the salary of a person based on the experience, right? So based on the data set, we supposed to create a best fit line, regression line. And how that regression line will be created and what is the formula used? I want your response in the chat box as well, students. What is the formula we can use, what we use in linear regression? What is the formula? The simple formula which we already had discussed, right? Y equal to mx plus c. Yes, exactly. So based on that formula, a best fit line or the regression line would be created. And we have to create a regression line in such a way that upon taking average of all the data points, the error rate should be minimized. There should be less error rate. Then this was the problem statement what we had done in the last session. That is ACME insurance INC. So we predicted medical charges of a person, right? So in today's session, we're gonna talk about classification problem statement. And in classification problem, we will focus on few algorithm that is called as logistic regression. Now, logistic regression works on classification problem statement. You have to keep this thing in mind that whenever we gonna use logistic regression, it is mainly used for binary classification. So binary classification in the sense like we are working on classification problem statement, whether it's gonna be raining or not raining, for an example, true or false, good or bad, yes or no, this kind of problem statements. We are trying to predict the outcomes. Now, you might be thinking that the algorithm name is logistic regression. Then why we are solving the classification problem, right? There will be a confusion, right? Like the name is logistic regression and we are trying to solve the classification problem. Can anyone answer me this? Why exactly is that so? Anyone who can just answer this? See, if you're wrong, also no need to worry. Like you can just put your response. Okay, let me repeat the question again. We are using the algorithm name called logistic regression, right? Now the name is telling that logistic regression. Regression means finding out the continuous number. But the name is logistic regression and we mainly use for the classification. Any idea? Okay. Okay, no worries. Let me just tell why exactly it is called so. See, the logistic regression, whatever the name, logistic regression, even though it is stating that it is a regression, we work on classification problem because logistic regression follows the formula of the linear regression. First, in last session we had learned about one of the formula, right? Linear regression, where we had y equal to mx plus c. The same thing will be taken with the logistic regression as well, and upon that there is a concept called sigmoid function. So sigmoid function will come into the picture in logistic regression, and by combination of both the things it becomes a classification. Now, the formula of the sigmoid function is very simple. It's like 1 divided by 1 plus e power minus z. So this is the formula. Now, based on this formula, what your model will do, it will try to classify two things. Okay. Now, sigmoid function will range the value from 0 to plus 1. 0 to plus 1. And 0 to plus 1, there will be two partitions basically. 0 to zero point 0.5 will be one partition, and zero point 0.5 to plus 1, there will be another partition. Okay, let me repeat it again. Now sigmoid function always range the value from 0 to 1, 0 to plus 1. And from 0 to plus 1, there will be a two partition basically. And one of the partition would be like from 0 to zero point 0.5, and another partition would be from 0.5 to plus 1. Now, if the data point is landing like around 0.3, if this is the output, upon taking out the linear regression formula, and when it comes to sigmoid function, and if sigmoid function is ranging at landing at like 0.3 value, that becomes it is in one specific group, that is from 0 to zero point 0.5. Okay, that one of the partition which was below, that will be considered as one of the specific class. So that is how logistic regression will work. The formula will be same what we had used in linear regression, and upon that, to add on the things, there will be a concept called sigmoid function. Will be there will be two partitions what will be taken off, and sigmoid function will range the value from 0 to plus 1. And on that there will be two partitions. 0 to zero point 0.5 will be one partition, and 0.5 to plus 1 there will be another partition. Let us have a look with another algorithm. That algorithm name is k nearest neighbor, KNN. Now in the picture you can easily identify like what exactly is happening here, right? So KNN basically is also one of the classification problem, mainly used for the classification problem statements. Okay, now let's believe that we have two different categories, category A and category B. Okay, now based on that categories, let's imagine that a new data point is coming in between. We are not sure where exactly it is coming. A new data point has came. Let's believe that this blue color data point, what you're seeing in the screen, it is the new data point. And your KNN algorithm, what exactly it will do? It will search for the nearest neighbor. It will tell search for the nearest neighbor. Now this new data point, the blue color, dark blue color data point, it will try to see which is the nearest neighbor for him. If category A is near to this new data point, that becomes, this new data point will become category A. If the category B is near to the new data point, that becomes the data point belongs to the category B. So that is how it's gonna classify the things. So that was the major difference in logistic regression and KNN. Okay. Students, is that clear? Is it clear? Understood? Yes. Okay. Let's talk about one more algorithm, that is decision tree. Okay. Now, decision tree is like tree structured algorithm based on multiple decisions. Your model will try to predict what exactly it is. And based on the conditions what we provide, your model will come to a conclusion. Okay. So this decision tree can work for both the problem statements. It can also work with regression also. It can also work for classification. Both the things can be done. Okay. Understand one thing. This decision tree algorithm can also be used in regression, and it can also be used in classification as well. To understand this decision tree concept, let's try to break this out. Okay. Now, I'll just give a simple example how exactly you can understand this decision tree. Okay. Let's believe that there is a person. Uh, okay. Let me give the problem statement first. The problem statement is you need to predict whether the person can accept the job or no based on the factors. Okay. Factors in the sense based on the data what we provide, based on the experience, based on the salary, based on the different things, location. You have to predict whether the person can accept the job or it can decline the job. Okay, that is the problem statement. Now let's believe that you have trained the model, and the training process goes something like this. Okay, now what happens key, your model will check all the decisions. Let's believe that one of the person has given interview in one of the company. Now that company has offered some X amount of salary for that person. Okay, let's believe that the company is offering $50,000 for that person. Now, what that person will do, he will check whether 50,000 salary is sufficient for the skill set he is having, right? So, if he is accepting the 50,000 salary, okay, what your model will do, it will check with the next condition. If the $50,000 is not sufficient for that person in the first decision only, your model will go for the declinement, which means it will easily decline that it's not gonna accept the job. If let's take another scenario that the person has accepted 50,000 salary, okay, what your model will do, it will check with next decision. The next decision would be like whether the company is located to what it's limited within the boundary where the person is locating. Okay, let's believe that the company is around like 15 to 20 kilometers from his home. Okay, in that case, what the person will do, he will accept the job. If the company is really far, like let's believe that 70 80 kilometers or more than 100 kilometers, what the person will do, he will decline the offer in the second decision. Okay, but if the company is near to him, if he is accepting it, what your model will do, your model will check some other decisions again. Okay, whether the company is giving cab facility. Okay, based on such kind of decisions, your model will come to a conclusion whether the person can accept the offer, or whether the person can reject the offer. Okay, that is how your decision tree will work. Any doubt in this, students? Any doubt? Yes. We have one more algorithm. This is the same algorithm what we had used in the previous session. For an example, we had worked on one of the problem statement for predicting the medical charges, right? I had used this algorithm where I got less amount of error rate. RMSE value was very low. Okay, let us understand how exactly this algorithm will work. Let's understand by taking a simple and easy example here. We can just take a simple example that there is a basket of fruits. We have different fruits, and I want to train my model, and I need to predict what exact fruit it is, right? So for that, I'll just train the train the model by telling that these are the fruits what are available and try to predict this. Now, what happens once when I use the random forest algorithm? There will be 100 different decision trees what will come into picture, and those 100 decision trees what they will do, they will try to predict what exact fruit it is. Okay, now let's believe that I want to predict what exact fruit it is. There will be some sort of data, there will be color, there will be size, there will be weight of the specific fruit. Based on that, what your model will do, it will call 100 different decision trees and it will ask you the answer for this fruit, and all the 100 trees will give different 100 answers here. Okay, now tree number 1 will tell that the fruit data what you have given, it's nothing but it's an apple. Tree number 2, it will tell again it is an apple. Tree number 3, it will tell that's something called banana. Tree number 4, again it will give something else. Okay. Tree number 5, again it will tell it is an apple. Okay. Likewise, all the 100 different decision trees will give different 100 answers. Now, what happens after that? Once all the 100 decision trees gives the output, gives the answer, the random forest model what you have created, it will check the majority voting. If the majority of the voting is given for apple, that means your random forest model will conclude that the data what we have provided, based on that, this is the fruit what we are trying to predict. Okay, so that is how your random forest model will work. And now this is just an example what I have given, that there will be 100 decision trees. Okay, so by default there will be 100 decision trees. You can also give the number of trees how much it's going to be trained out. Okay, so in simple terms what you can tell that is this random forest is called as one of the most powerful algorithm. Okay, and it can also solve regression and classification. Both the problem statements can be solved in this random forest algorithm. Okay, let's talk about few evaluation metrics as well. Now, in the last session we had talked about regression problem statement, right? And we uh, had taken one of the evaluation metrics, that is RMSE, that is root mean squared error. That is not only the evaluation metrics what we will be using, there are other evaluation metrics also in regression. You can see that is mean absolute error, mean squared error, root mean squared error, that is the evaluation metrics what we had used in previous project. We have R squared, adjusted R squared, and mean absolute percentage error. So these are the evaluation metrics used in regression problem statement. You can use it accordingly. When it comes to classification, there are different metrics what we will be using. One of the metric is accuracy score, balanced accuracy, precision, recall, specificity, F1 score, and correlation coefficient. So these are the evaluation metrics in classification. But if you want more detailed evaluation metrics, you can just use one of the function while once your model has built, that is classification report. Over there you can just get the entire precision score, recall, F1 score, etc. Okay, now let me just talk about one of the problem statement what we gonna discuss in today's session. Okay, the problem statement is very simple. Now let me just tell what exactly the problem statement is. Okay, And before explaining the problem statement, I want each and everyone to go through this problem statement what I have given here and try to understand this thing. I'll just give 1 or 2 minutes so that you can just understand the problem statement and you have to tell me what exactly we have to do in this. Okay. Yes. Now, those who have understood the problem statement, can you just post your comments in the chat box like what exactly we are trying to do here? Just understand the problem statement. Just read out the entire context and tell me what exactly we are trying to do here. Okay, it is a classification problem. Okay, understood. Predicting the risk of car being kicked off. Okay. Calculating the risk. Okay. Whether it is a good purchase or a bad purchase. Okay, well, good. Classify the car is in good condition or bad condition. Okay, fair enough. Tampered or not. Raghav, can you just tell me like what exactly is tampered or not? Can you give more clarity on that? Refurbished car price prediction. Changing the readings of how many kilometer car has been run. Okay, well, okay. Let us see about the problem statement here. Now, the problem statement is very simple. It is telling one of the biggest challenge of an auto dealership, which means automotives. The dealership is telling that purchasing a used car in an auction, it will be in a higher risk. Okay, let me just complete the entire sentence. Then let us understand this. Okay. One of the biggest challenge of an auto dealership purchasing a used car at an auction is the risk of the vehicle might have serious issues that prevent it from being sold to customers. The auto community calls these unfortunate purchases as kicks. Now, kick cars often result when there are tampered odometers, mechanical issues. The dealer is not able to address the issues with getting the vehicle title from the seller or some other unforeseen problems. Kick cars can be very costly to dealers after transportation cost through away repair work and market losses in the reselling the vehicle. Okay. So in this project, we will see the cars which has higher risk of being kicked, which can help real value for dealership and provide the best selection for the customers. We will look at real world data for 1,50,000 customers and use machine learning technique to build a model. Now, in the auto dealership, one of the major concern is the used cars. Okay. Whatever the used cars will be coming into auction, right? So the purchase of the auction, whether it is a good purchase or a bad purchase, we have to figure it out that way. Okay. Because there will be a lot of factors we have to understand here. We have to check whether the vehicle is having any serious issues or uh, whether it is like waste of spending on that what auction, etc. A lot of things are there. That is the major concern. We'll try to resolve this. Okay. Let me just, okay. Yeah. Student, just let me know whether my project screen is visible. Yes. Okay. I have given the project name as Don't Get Kicked. Okay. So mainly we are trying to predict the uh, vehicle, whether it is a good purchase or a bad purchase. Okay. We have various factors, what we have discussed, and we have also understood the problem statement. Okay. So the problem statement is very simple. We have to check the vehicles, whatever the vehicles coming into the auction, whether it is a good purchase or a bad purchase. Okay. For working on this, we have approx 1.5 lakh of customers data. And for those customers, we'll be applying machine learning technique for those data of the customer, what they have provided. We're gonna implement one of the machine learning technique and we're gonna build a model for that. Now, this is the description of the data. Uh, I have written a clear detailed description here. The same files will be shared in the Telegram group after this specific session. Okay. After the session, like both project template and whatever the projects we have done, those things will be sent in the Telegram group so that you can just refer that and you can start working on the projects accordingly. Now, these are the few columns what we have. We have a reference ID, that is unique sequential number assigned to a specific vehicle. Okay. There is a column called is a bad buy, is bad buy. This is a column name. It is telling that identifies if the kicked vehicle was avoidable purchase. Okay, which means let's see what data we have in that. Let's try to understand the columns first and let us look into the data. Okay. We have a column called purchase date. So the keywords, what they have used in the column, they are short. They have used the short name. The detailed description I have written at the side. You can just read it accordingly. We have something called auction provider at which vehicle was purchased. Okay. We have something called vehicle year, vehicle age of the vehicle, the manufacturer of the vehicle, make, model in the sense what is the model of that vehicle. There's something called trim level of the vehicle. We have sub model of the vehicle. We have the color, what type of transmission it has, wheel type. Okay, so we have wheel type ID and wheel type. These are two different columns. We need to check out each and every factor. Vehicles odometer is there, odometer reading, like how many kilometers it has been driven. Nationality, where exact, what is the origin or in which specific country the vehicle got manufactured. We have size, top three American name. I'm not sure what exactly it is. It is telling identifies if the manufacturer is one of the top three American manufacturers. Okay. Then we have other different values, some average price, clean price, average price, etc. Okay. So these are the different factors what are included in the data. Now, in this specific project, this is the outline, or this is the project outline what we're gonna perform. Okay. Installing and importing all the required libraries. Okay, if the libraries are not available, we're gonna install it. Okay. And the second thing is downloading the dataset from the Kaggle. We're gonna perform EDA, exploratory data analysis, because if we understand the data very well, doing the analysis or building the model would become much easier. We're gonna implement feature engineering. We're gonna prepare the data set for machine learning training. We're gonna create one of the baseline model. Then finally, we're gonna train with different models. We'll also try to tune our model, which means we'll try to improve the model here. Then we'll see what is the final model. And we can also talk about future work ideas. of the project as well. Okay, so that will be the complete project outline. Okay, so this is the simple project outline what we have created. If you are if you want to build machine learning project, even you can just figure out what are the things what you can keep in your project. You can also allocate based on your requirement. Okay, now we'll be using this few libraries here. I'm not going to install any of the libraries because all the libraries are installed. I'm just going to import all the libraries here. So one of the library is pandas here. Pandas is one of the library of Python, mainly used for analyzing the data for data manipulation. Then we have NumPy library. NumPy is one of the library of Python to perform numerical computing. Okay, so NumPy stands for numerical Python. We have Matplotlib for visualization. Again, Seaborn for the visualization. We have another library that is open datasets. Now, this is one of the library where it takes the URL and it's gonna extract the URL and it's gonna download the dataset for you. Then we have another library that is Plotly Express, mainly used for visualization, more advanced visualization compared to Seaborn. Okay, so these are the few libraries what we're gonna use. Any doubts still here, students? Is everything clear? Shall we start? Yes. Now, basically, I'll be okay. I think I have already. Let me just check. I need to import the libraries here. So these are the libraries what I'll be using, and there is a URL here. The URL is very simple. This is the link basically what we have used. Okay, don't get kicked is one of the folder and where the entire dataset is available. Now you can just copy this URL link here and you can just open in the new tab and check what exactly it is. You can see the Kaggle website will be opened here where the data is available. Directly, you can just download the data from here. You can see download option is available here. Okay. So once the data set is downloaded, what you can just do is you can come back or you can read it directly. Okay. So other things are also available. You can just what you can just do is once the file is been downloaded, you can just read the data directly. Okay. Now here you can see here, I have created two variables. One is the train data and one is the test data. Now, as of now, let's not focus onto the testing data. Let's concentrate on train DF here. Now, what I'll be doing is from the pandas library, I want to read the CSV file. And in that CSV file, there is a folder don't get kicked. And I have a data set here. That's nothing but training. And the format is nothing but CSV, which means comma separated values. Now, once I just run this, you can just check what is the data we have in this. Okay. Once I just use trained here, this is the entire data what has been executed. Now, in this data frame, you can see we have a column called reference ID. There's a column called is bad by, purchase date. We have column called auction, vehicle year, vehicle age. We have something called make, model, trim. Lot of different columns are available. Now, once you look at the data here, you can just see here in the entire data, we have approx 72,983 rows and we have 34 columns inside that. This dataset contains approx 73,000 rows and we have 34 different columns of the dataset what we have taken out. Okay. Now, if you just want to understand the data very well, what you can just do is this is the variable what I have used, print here, where the entire data has been stored. I'm using a keyword called info. Now, info will give you the summary of the data here. So you can just run this traindf.info. And now you can see that entire information will be provided here, the summary of the data. It is telling that total 34 columns is been provided. And these are the column names. We have reference ID, is bad by, purchase date, auction, vehicle year, vehicle age, make, model, etc. Okay. Lot of different column names are given here. Okay. Now let's try to understand what exactly we are understanding by using this info keyword. One thing is clear that we have 34 columns. Okay. And there is something called non-null count. Now this non-null count basically means that non-empty value. In the specific columns, how many non-empty values are present? Okay, it will help us to understand like how many empty values are present in each and every column. Okay. Now, if we talk about this column called is bad by. Now, this column has 72,983 non-null values and the data type is nothing but int64, which means it is having the integer values. Integer values means whole numbers. Okay. I'm not sure what kind of values are available. Let us have a look again. Okay. We have another column called purchase date. Now a purchase date also contain all the values. It is having 72,983 and the data type is nothing but object. Now, can anyone tell me like why exactly we have object values over there? Why exactly it is object? Text data. Okay, it is a string value, right? It is a string value. That is the reason we are giving object. Okay, so why exactly it is called as object? See, purchase date, there will be a date, right? So if you talk about date in the data frame, it will be something around here. Yes, we can just have a look. We have 12/7/2009. Okay, now this specific value is containing slash. Now basically slash, if you want to include slash, you have to obviously make it in the string value, right? So if you just remove the slash, it will become integer. Okay, so because of this slash, it is giving the object values. We have to do a lot of pre-processing to that so that it can what you can prepare it for the model building. Then we have a column called auction. Again, auction is telling that the data, whatever we have, it's nothing but the object. Vehicle age we have, make, model, lot of things are available. And you can see there is a column called wheel type ID and there are few missing values. See the previous values, we have 72,983 and when it is coming to vehicle ID type, it is having only 69,814 values and rest of the values are completely missing. Now what happens while doing the survey, everyone will not give the entire data. So few of the values will be missed. Okay. So that also we have to keep in mind. Okay. Yes. Now again, we have test data. So I've already told we not gonna talk about test data here. Okay. So let's directly come to EDA part now. Okay. I'm taking a variable called A. Now in the variable A, what I'm doing is I'm just taking the entire train data and there is a column called is bad by. Okay. And from that is bad by, what I'm doing, I'm just checking the value count. Okay. Let me just show you what exactly happens over there. Just a minute. Yeah. Let me add the new cell here so that you can understand much better. Okay. Now you can see I'm just taking the entire train DF here and there's a column called is bad by. Okay. And there's a keyword called value counts. This is one of the Python function. Okay. Predefined function. And if I just do that in the column called is bad by, it will give what are the different types of values are available. So it is telling that there are only two types of values, that is 0 and 1. Okay. And 0 is been repeated 64,007 times and 1 is repeated 8,976 times. Okay. So by understanding this thing, what we can come to a conclusion is 0 basically means that, see, the column name is asking is bad buy. So 1 means basically it's a bad buy and 0 means it's not a bad buy. So out of that 72,975 vehicles, 64,000 were a good purchase and approx 9,000 vehicles were went into the bad purchase. Okay. So the same thing we are trying to create a chart over here. Okay. Okay, no worries. It is not creating a chart here. Directly, I can just do it here. I can use a plot function and I can just give what kind of chart I want. I'll just tell that I need a bar chart. Okay, there might be some error here. Okay. No worries. Instead of creating the charts, what I can just do is I can just create the values here so that later on I can create a chart here. Okay. So in the column called is bad buy, I have 64,000 good purchase vehicles and approx 9,000 vehicles, which is the bad purchase. Okay. That is one of the conclusion what we have came. Then again, what we can just do is I can also check what are the different auctions. Instead of creating the chart again, I'll just write the manual code and I will show it to you. So here I'm taking the entire train data and picking a column called auction. And again, I'm just checking the value counts here. Now, once I run this specific thing, you can see that there are specific three different auctions. One is Manheim, other, and Adesa. So these are the three different auction which has been taken place and all the data is been taken out. So from Manheim, like there are 41,043 vehicles and there is something called other where we have collected 17,501 vehicles and Adesa has 14,439 vehicles. Now, if you still have the doubts, like what are the unique values are available, you can uh, check it out by writing the code here. What you can just do is you can just use traindf dot. You can use that column name that is auction here. And you can just simply apply a keyword called unique. Okay. Now, once you apply the keyword called unique, you can see these are the three different what we call values what are available. The same thing it has been given. One is the Adesa, other, and the Manheim. Again, we can also do few more things here. We can also check the vehicle age here. Let me just create another cell here. Okay. So I'll just use from the trained EF. Okay. I'm gonna take out a column called vehicle age here. I'll directly copy from this. Let us see what values we have in this. Okay. So you can see that in the column called vehicle age, we have the values like 3, 5, 4, like how old the vehicle is. Okay. Those values are available. Now to understand much better, what we can just do is I can just simply use again value counts so that I can get a clarity, like how many new vehicles are there, how many old vehicles are there, etc. So I'll just copy the same thing here. I'll apply a keyword called value counts here. Yes. Now you can see there are 17,000 vehicles, which is 4 years old, 3 years old vehicles, which is like 15,902. Again, 5 years vehicle, which is like 12,956. Like that, it goes on. Okay, so you can just understand each and everything. See, if you want to check highest values, what you can do is, if you want only the top 5, you can apply the head function so that you can get only the head function as well. Or else, if you want the values in terms of percentage, you can also take it in the percentage as well. What you just have to do, you just have to use normalize equal to true here. You'll get all the percentage values and you can multiply into 100 here. Okay. Yes. Now you can see that in this data set, 23% of the vehicles are like 4 years old, 21% of the vehicles are 3 years old. So if you just take an average, like hardly most of the vehicles are ranging like 3, 4, and 5. Okay. If you include this 3, 4, 5 years vehicles, it's dominating around 60% of the entire vehicles. Right. So that is how you can just understand each and every factor from the data. Any doubts still here, students? Okay. See, again, let me just tell you one thing. Whenever you start building any machine learning model, you have to understand the data very well. If you understand the data very well, then creating the project will be easy. Okay. As much you have some idea about the data set, that is the easiest model what you can create. You'll be having a clarity what exactly you're trying to do. Okay. Yes. There is another specific column that is called as make. Let us see what we have in that. Okay. Let us see the column first, what exactly it is. Okay. To check the column, I have to simply use entire data set trained here dot the column name here, that is make. Now it is telling that the make is like Mazda, Dodge, Ford, Mercury, Chevrolet, etc. So these are the different makes what we have in the data here. Now, see, this is not only the way how you can check out each and every values. You can also use the square brackets to check it out. The other method is you just have to remove this, apply the square bracket, give the column name in the quotation and close it up. Both the things work the same way. Okay. Either you can just use the dot function or else you can just use this method as well. Both are really simple. Okay. Now from this train DF, what I have done, I have I'm just checking out the make here. Make in the sense like what are the different companies especially. Okay. So if you just look at the description of the data set, make basically means that it's nothing but the company of the vehicle. And you can simply use value counts. Again, instead of that, I can just, yeah, you can have a look here. These are the, let me make it as head here. These are the top 5 companies. Okay. Top 5 companies which is having most number of vehicles. One is Chevrolet, one is nothing but Dodge, Ford, then Chrysler or Pontiac or something. Okay. Now, if you just want to check bottom 5, instead of the keyword called head, what you can just do is you can replace it to the keyword called tail. And if you just try to run here, you can see that for the auction, these are the vehicles. Again, it came for the auction. One was the Hummer, Toyota Scion, Plymouth, Mini, and Subaru. Okay, so these are the few vehicles again. Or let me make it as head here so that. Okay, I think I have already created this one. Okay, so these are the head function I've used as value as 10, which means top 10 vehicles. Chevrolet, Dodge, Ford, and Kia, Saturn, Nissan, Hyundai, and Jeep is being followed here. Also, what you can just do is you can understand each and every step, what is happening here. Okay. And you can just write down the document at the bottom. See, once you understand the analysis of the data here, after understanding the make column, you can just write down the insight what you have understood from the specific code, so that it becomes much easier for the people to have a look like what exactly I've done here. Okay. The insight I have written here, Chevrolet is the company which people have purchased the vehicle a lot. Okay. Now what I've done, I'm creating few charts here. Now I'm using PX. PX basically it's nothing but the Plotly library. And I'm using a function called histogram. Basically what I'm trying to do here is I'm plotting a histogram. For the histogram, what I have done, I have given the entire trend EF here. Entire data set I have given. And histogram takes two axes. One is the x-axis. Sorry, it takes only one axis. Okay. I have given x-axis here. And to check the histogram, I have given the vehicle age. Now, basically, histogram gives you the distribution of the data, how exactly it has been distributed. Okay. Now, in Python, if you want to check the distribution of the data, the simple and useful chart what you can use is histogram. Okay. Now, histogram is mainly used for checking the distribution of the data. If you keep that thing in mind, it's clear. Okay. Again, let me just tell, I'm plotting a histogram here and I'm taking the entire data. In the x-axis, I have taken the vehicle age, age of the vehicle. I have given color equal to is bad by. Now, basically the column called is bad by have two different values, that is 0 and 1. 1 basically means that it was a bad purchase. 0 basically means that it is a good purchase. Now to show the difference of both the readings, I have created a color for that. You can see at the end, is bad by have two values. 0 means it's nothing but in a blue color. 1 is nothing but the red color, and which means the vehicle what we have purchased is it is the bad purchase. Okay. Now by seeing this chart, we can easily tell that a lot of vehicles are from age 3, 4, 5, and 6. You can also include 2 as well. Majority of the vehicles are ranging from 2 to 6. Okay. And there are few vehicles where vehicles age is like going like 9 years as well. You can have a look. And there is only one bad purchase where the age is 9 and the count is 202. So there are basically 202 vehicles, 202 vehicles of age 9, and out of that only one vehicle which came of the bad purchase. Okay, so that is how you can understand each and every factor here. Let's check out something else. This time I'm just using again I'm using histogram here. I'm passing the entire data here. In the x-axis, I'm passing the column called make. I'm checking what are the companies of the vehicle. Again, I'm checking which company has the bad vehicle category here. Okay. Let me just try to run this. Okay. Now we can come to a conclusion that the company Chevrolet have lot of vehicles which is going in a good purchase. And okay, 15,567 vehicles were the good purchase and 1,681 were the bad purchase of the vehicles of the company called Chevrolet here. Okay. Now there are other companies also. You can have a look here. Dodge, which is like 11.579K, which is good purchase, and 1,333 vehicles were in the bad purchase. There are other companies also which is showing the bad purchase. You can see the reddish bars here. Even Subaru is showing the red color. Then we have Lincoln, bad purchase. Infinity, which is the bad purchase. Lexus, Acura, then Plymouth. Okay, so these are the companies which is going under the bad purchase as well. Okay, so these are the things what we can just look ahead and understand each and everything. Okay, you can also check the nationality here. To check the nationality again, I can just simply use histogram. See, we are not recommending that you have to use only histograms to understand the chart. There are other different charts as well. Each and every chart gives you the different insights. Okay, so in histogram again, we are just classifying the nationality and we are checking with the bad buy here. Okay, so American vehicles and these many bad purchase were there. 7,387 were the bad purchase and almost 54,000 were the good purchase. And Asian also you can see here, other Asian basically, which is going like 7,000 good purchase. And when we talk about bad purchase, it is showing like 1,000. Top line Asian, again, I'm not sure what are the countries coming under this top line Asian. You can do some manual research and you can just get it sorted. You can just check all the sizes of the vehicle. Size in the sense like whether it is a medium, large truck, compact, van, whether it is medium SUV, large SUV, etc. Okay. So medium vehicles are being sold in huge amount of numbers. Okay, in terms of count. Okay, and large trucks as well. You can see here quite few numbers, and out of 2,810 good vehicles of large truck, there are 360 bad purchase of the large trucks as well. And even the sports cars as well, you can have a look. The good vehicles were 633 and bad purchase was 144. Okay, that is how you can just check each and everything. There's again another column called VNST. I'm not sure what is that VNST. You can cross check here what kind of values we have in that VNST. Or let me just create here. Let me just check the column. Printf dot VNST. Okay, probably I can scroll up and check the description, VNST, right? Okay, we have here VNST. Okay, it is a state where the car was purchased. Basically, it is nothing but the state. See, they have used the short keywords in the data. So we have to clarify what exact that column tells us. Okay. So that was the reason I have written the entire description over here. So let's try to see that. Okay, somewhere here, right? Yeah. So these are the different states, I guess. This FL, I think it is nothing but Florida. VA again, I'm not sure. I think you can think, right? So there are different states in America. What you can just have a look. Again, the easiest states what we can just suggest is TX. That is nothing but Texas. FL, Florida again. CA, which is nothing but California, right? These are the few specific states where huge amount of vehicles is being sold. Okay, so you can also do the manual research and you can just get more clarity on that. We have wheel type again. We are checking with the wheel type. Just a minute. We are just checking with wheel type whether it is a bad buy. Is there anything related to that? No, I guess. So you can have a look. These are the vehicles: alloy wheels, covers, and special wheels. Okay. So most of the vehicle have alloy wheels only, and standing with covers, and hardly few vehicles are there which they have the wheel type as special category. And only 99 vehicles are there which is having the special wheels out of approx 75,000 vehicles. Okay, so let's talk about some other different plots here. Not only histogram, like we have another plot called scatter plot. Basically, it creates a data points, and scatter plot takes two different axis. Okay, it takes x-axis and y-axis, and based on that, it's gonna create the chart for us. Okay, so in the x-axis we have kept acquisition auction average price and acquisition retail average price. I've taken these two different columns to understand what exactly it is. Okay, let's try to create the chart here. Okay, and you might be wondering that why only few data points has been taken out here, right? So because I have taken only, okay, I think I have taken only the sample amount here. I can also give uh, the values here. I can just use a head function where I can just use only 1,000 values. Okay, like this, so that you can also reduce the data points here. It's not that you need to plot each and everything. You can just pick starting 1,000 rows and you can just create the chart for this. And I believe that the blue color is nothing but the good purchase, and the yellow color, what you are seeing, I think it is going into the bad purchase. Yes, here we go. Dark blue is the good purchase and yellow color is the bad purchase. Based on the values, you can see that we can come to a conclusion here that the vehicle's value which is lying very small, like which is ranging like 2k to, sorry, it's not 2k, I think average price, I guess, yeah, have lot of yellow color uh vehicles here. I think this can be minimized if you reduce this. Okay, I don't see that much changes over here, but we can assume one thing. Okay, let me make it as 10,000. Okay, lot of blue color points are coming out compared to yellow colors. Yes, you can also work accordingly. Okay, now let us also perform few pre-processing techniques here. Okay, so there is a keyword called isNA. Now isNA basically means it's nothing but you are checking is empty value. Okay, so you're just checking whether any of the column is containing any missing values or no, right? So basically TrainDF takes the entire data, right? Out of that entire data, we are just checking all the empty values. Either you can use isNA or else you can also use isNull. Both the things work the similar way. Okay, you can use whatever you want. Either you can go for isNull or isNA. Anything is fine. Now you're just using traindf.isNull and you're taking the sum of that. Let me just remove this as of now. Okay. Now, once you do this, you can see all the columns, how many missing values are available of that. Okay. So is bad by purchase, auction, vehicle year. These are the columns which they don't have any missing values. And there is a column called trim where it is having 2,360 missing values. Again, submodel has 8. color has 8, transmission 9 missing values are there, etc. I think at the bottom, like we have two different columns, that is prime unit and some one of the column which is having approx 70,000 missing values. Okay, so you have to keep one thing in mind. If you have huge number of missing values, easily you can go ahead deleting that column. Why? Because that column doesn't mean anything for you. Okay, you cannot get any kind of insight from those. See, prime unit is a column where you have approx 70,000 missing values out of 75, I guess. I'm not sure. Okay, so in the data set we had a few values, right? Okay, out of that almost 70,000 missing values are there. You can just cross check with the, okay, wait, divided by, let me just take it in terms of percentage. Okay, okay. Yes, it is showing 95% of the missing values. Okay, so if the data set is having huge amount of missing values, you can directly go ahead with deleting this. Okay, we don't require this. 94.5 of the missing values doesn't give any insight. You can easily drop those columns. Okay, so if you have 4%, 3%, yes, it's acceptable. Okay, so we have a lot of imputing techniques what we can do for that, because whenever you're creating a machine learning model, okay, in the machine learning model, if you have empty values, your model will throw an error. So before putting the data into the model, you have to cross check whether entire pre-processing has been done. Okay, you have to fill out all the values. You cannot give empty values to that. There is another column called is online save. Okay, see, to make it more simple, if you want to check that, I can just use traindf dot columns. So if you just use traindf dot columns, all the column names will be displayed here. You're not getting each and every values here, but you can highlight all the column names here. You can look at this. We have a column called is bad buy, purchase date, auction, vehicle year, vehicle age, make, model, trim, submodel, color, transmission, etc. Right? So this is what we had understood from the entire ADA. Okay, so by performing exploratory data analysis, we have understood few of the things, right? What exactly is available in data and what are the things we can just do it. Okay, so a lot of students are having a question that what kind of project can be done, right? Project ideas. So what we will be doing is, we'll be sharing few project ideas. Okay, student, listen carefully that we're not expecting the entire project, whatever you are doing, to be precise and to be accurate. Okay, we want you to put all the hard work in that project. Okay, even though your project is not working that good, but it should be working fine. Okay, and few of the project ideas we'll be sharing with you. No need to worry. We'll just create one of the sheet and we'll be sharing the sheet with you in the Telegram group as well, so that you can also work on few problem statement based on the project what you can just work on. Okay, no need to worry. We'll be sharing few ideas, project ideas as well. I know a lot of questions are coming up regarding projects. No need to worry. We are here to help you out. We'll be sharing few project ideas as well. Yeah, I'm going to tell you about the project guidelines also, like what are the things should be there. Okay, what are the projects, what are the things should be there, and what are the things you can just do it in that. Okay, no need to worry. Okay, kindly stay tuned till end of the session. Okay, so entire details will be provided like uh, in the end of the session. See, if the entire project is not yet done in today's session, that will be continued in the next session as well. Okay, I'm focusing a few of the pre-processing techniques for you people here so that you can understand much better. Like in previous session, like we completed the entire flow by executing the codes, right? But I'm going to show you like how exactly pre-processing can be done and what exactly you can do it in the pre-processing as well. Okay, I'm going to take some time in the project part. Yes. Okay, so these are the few columns what we have taken out. Okay, so we had is bad by purchase date auction. Okay, so to build machine learning model, we are not requiring the entire columns. Okay, we don't require entire columns. We can just pick specific columns which would be better enough for our predictions. Okay, so providing all the columns is just wastage of the memory and time as well. Time in the sense execution time would be much what lengthier. Okay, much higher execution time will be high. So you can select those specific columns which is having a perfect fit, and you can select the best column where your model can learn each and everything. Okay. Now we'll start with the data pre-processing here. There is a column called transmission, right? Now in the transmission column, if you just check all the unique values, these are the values what they sorry for the glitch, students. Yeah. So I was just talking about data pre-processing, right? So we have entire data here, and in the entire data, there is a column called transmission. Now, in the column called transmission, these are the different values what we have. We have a column called auto, we have manual. There are a few missing values over there, and there is another column called manual. Now, you already know that Python is case sensitive language, right? So it detects all the uppercase characters as different value and lowercase values as a different value. Now what we can just do is we can just merge this manual value in together. Okay. To do that, what we can just do is I can simply use a replace function. Okay. Now let's see how exactly we can do that. See, I'll just execute the code here. And let me also just check the value counts as well. Okay, I'll just check the value counts as well. Okay, so we came to know that there are 70,398 vehicles, which is the automatic cars, and 2575 manual cars, and there is another one single value which is having the lowercase characters. Okay, so this I need to put it into this specific manual value. Okay, for that I can simply use a replace keyword. Okay, now let us see how exactly we can do that. I'll just take the entire train here, and there's a column called transmission, and I'll apply a keyword called replace. Okay. And to apply the keyword called replace, I'll be using the dictionary function. Okay. Now this would be the key, and this should be the value for that. Okay. So wherever there is manual, I'm making as this as a manual. Now let us see this. Okay. Let me just check the transmission now. I'll copy this value counts. Again, I'll just test it out here. Okay, did not get replaced. Just a minute. I need to check whether the spelling what I've provided it is correct or no. Okay. There is a minor mistake what I had done. I had given lowercase m here. Okay. You should be checking each and everything. Now it is working. See, small glitches will be there. You have to check each and everything, whether you have given the right things or no. Okay. Why? Because we are using Python language, right? It is the case sensitive language. You have to continuously check each and everything. Now it is working fine. Okay. Now there are only two values here, auto and manual. So 70,398 automatic cars are there and 2,576 manual cars are there. Okay. Now again, let us check all the missing values of all the columns. Okay. And these are the columns which have the missing values. And now what we can just do is we can just go ahead with dropping few columns, which is not required. Okay. So we'll start with a column called trim. So there's a column called trim. Let us see what trim column has. We are going ahead with dropping that column because from the column called trim will not get sufficient knowledge. Okay. And we are also dropping the model here. Now, can you tell me like why we are dropping the model? Can anyone answer this? Why we are dropping model column? Compared to model column, what other column has the value? Can anyone figure it out? This one? Too many names? No. Because it has less priority. See, manufacturing of the vehicle it plays a really important role, right? Yes, exactly. We have a column called make, right? We have a column called make. Now, if we have the column called make, then we don't require model because we have another column called submodel as well. You can cross check here. We have column called submodel and we have a column called make as well. So we don't require model now. Okay. See, you have to think each and everything because if you are just giving the entire data directly, your model will get trained, but it becomes execution time would be much higher. So try to reduce all the things. Okay. Try to minimize each and everything. Don't use unnecessary data. So instead of the column called model, I can go ahead with submodel where I can just get more information. And I have a column called make as well, where I can just get the company, what exact company it is. Okay. Yep. Then we are dropping the column called reference ID. We don't require reference ID. Okay. That's not required. We are dropping the column called vehicle here again, because I think instead of that, we have another column called age of the vehicle or something. Vehicle age we have. Vehicle year and vehicle age both gives the same results or same insights. So either we can go ahead with dropping one of the column. Okay. So in this case, I am dropping a column called vehicle year. Wheel type ID. I don't think that we require that column anymore. Let's see what we have in that. I'm just checking that column here. We have the ID column. So I think we don't require that. That is the reason we are dropping that. Okay. Then we have something called VN ZIP1. We are not sure what either that is. Okay. So we are even dropping that. We have some values over there. Okay. See, if you're not sure like what exact value is it, and if it is not affecting your model, you can directly go ahead with dropping the columns. Okay, we are dropping unnecessary columns. We are even dropping the prime unit. We are also dropping this org guard something, and even the purchase date as well. So once we drop this, now you can just check the describe function where I can get the statistical analysis of the entire data here. Now, statistical analysis basically gives you the concise summary, and it works only for the numerical values. You can see all the data, all the columns where we had numerical values, we are getting the insights now. Now, is bad by was a column where we had 0 and 1. So that is the reason we are getting a statistical analysis of that. Okay. So to get the statistical analysis, you can simply give the describe keyword here. Okay. Now minimum value is 0 and maximum value is 1. Why? Because we had only two values, 0 and 1. So it doesn't give any insight. You can focus on to another column. Vehicle age. Now in the vehicle's age, the minimum age of the vehicle is 0. Okay. And maximum age of the vehicle is 9. See, when the vehicle is coming from the showroom, also there might be a few chances that it will come under the auction. Okay. Yes, like hardly the vehicle is driven only for 2 months or 3 months. It's not yet completed 1 year either. Okay. Even in those cases also, the vehicle will come into auction as well. There might be other factors why exactly it will come to auction, because there might be some issue in the engine or some different reasons might be there. We have to check accordingly. There's another column called vehicles odometer readings. The minimum, the lowest vehicle driven in the entire data set is nothing but the kilometer in terms is 4,825, and we are not sure which vehicle it is which is driven that less. Suppose if you just want to check which exact vehicle it is, you can apply the filter here. To apply the filter, what you can just do is you can simply apply, you can give a keyword train df, and this is a column name, right? Train df. Okay, again I have to give it. I'm applying the filter here. This is a column. Whenever you are using square bracket, you have to use the colon. Make sure that, and you are assigning this specific value. What is that value? 4825. Let's check what exact vehicle it is. Okay. Now this was the vehicle, and it is also telling that the purchase is a bad purchase. Okay. It was auction in other thing. The age is only 3. The make is Ford. Okay. And it is coming into the bad purchase. You can check each and every factor here. Now this vehicle is driven only 4,825 kilometers. Okay. There might be some problem in that vehicle. Okay. And nationality is American. These are the prices came into the auction, and it is from the Texas. Vehicle cost they are giving as 225. I think it is the dollars. 225 vehicle B cost. I'm not sure what exact that column means. You can cross check. You can scroll up and you can cross check over there. Okay. Yeah, that is what the lowest what driven vehicle. This is the minimum driven vehicle. That is nothing but Ford. Then there are few vehicles which is driven a lot here. Like it is 1,15,717. You can also check this specific vehicle, which is this vehicle. You just have to replace the value here. Okay, even this is coming under the bad purchase. You can see even this vehicle, whatever the value what I have given. Okay, I'm matching the vehicle here. Even this vehicle is coming in the under the bad purchase. The auction was taken from Manheim. And again, the vehicle is nothing but Ford. Okay. The age of the vehicle is 6 years old. This is 6 years old and it is driven a lot. We are not sure what might be the reason, but it is coming under the bad purchase. Okay. So that is how we can understand each and every factor from the data. Okay. So Tirath is asking like why train DF I have used 2 times, right? Because I'm filtering the data. See, understand one thing here. This train DF basically means that I'm taking the entire data set. In the entire data set, I have 34 columns, right? Now, out of that 34 columns, what I'm doing, I'm filtering one of the column that is from the train DF, what I've taken, there is a column called vehicle odometer. Okay. So there are 2 things. This is the entire data frame. From the entire data frame, I'm applying a single filter where this value should be equivalent to this one. Is that clear, Tirath? Yes. Okay. Now, once you're done with that, what I can just do is I can separate the targets now, targets and the inputs. Okay. Now you have, see, whenever you build any machine learning model, you have to separate the inputs and the targets. If you have attended the last session, you might have seen how I have given the inputs and what I had given the target column. So in this specific data set, I'll just show all the columns here. Let me just give it here. Train DF dot columns. Now, this is the data set. These are the column names. Now, students, can you just tell me from this data set what exactly we are trying to predict? Which column we are trying to predict? Which is the column we are trying to predict in this data set here? Is bad by, right? We are trying to predict a column called is bad by. Now just tell me what is our inputs? What is our inputs? Except the column called is bad by, all the other columns will become our inputs, input data. Okay. So there are 2 things what you have to remember here. We have to separate all the input data and we have to separate the output data here. Okay. So in the input data, except the column called is bad by, all other columns will become input data. Now what happens for this column called is bad by? This column will become the target column. Target in the sense, this is the specific column what we are trying to predict. Okay. To separate both the things, what I have done is I have taken a variable called train targets. In the variable train targets, I am filtering out from the entire train DF. I'm picking only one column, that is bad by. Now all the things will be stored in the variable called train targets. Now you can cross check now. Let me just write it here. Now I have executed this code here. Once I execute this, if you just check the variable called train targets here. Now in the column called train targets, sorry, in the variable called train targets, there is a column called is bad by. Only one column is there, is bad by. Okay. Now what I'm doing for train DF here. Now train DF basically means these are nothing but the inputs. Except is bad by column, all other columns are included here. Except this column called is bad by, all other columns are included. You can cross check now. I'll just check train DF now. Train targets is different and train DF is different now. Now you can see previously we had one column called is bad by. which is successfully removed now. We don't have is bad by column now. We are starting with a column called auction, vehicle age, make, etc. If you want to cross check, you can apply the keyword called columns and check it out. Look at this. So previously train df had is bad by column, and now I have removed this because I have applied the drop function in the entire data set, because I want to make this entire train df as an inputs and train targets as my column what I need to be predicted out. Is everything clear till here, students? Yes. For training the data, we will drop the column called is bad by, so that I can give it as a target column, and other columns will become my inputs. This is the same thing what we have done. We have done the splitting here. Now, can you tell me what is our independent data and dependent data? Or dependent variable or independent variable? You can just write down the text in the chat box. This is our dependent variable and this are our independent variables. What are our independent variable? Okay. All inputs are dependent. Suresh, can you just rethink? See, all input data, all the inputs are the independent data. Okay. All input data are our independent data, and the is bad by column, the target column, is our dependent data, because if I get some inputs, then only I can predict something, right? Yes, inputs become our independent variables and target will become our dependent. Target is dependent on the inputs. Don't get confused here. Yes, is bad by is our dependent variable here. Okay. You can also check all the head function. Okay, now we have 24 columns. Okay, so in the train data here, we have only 24 columns. Rows, all the rows are same, I guess. I'm not sure. Yeah. There are 72,983 rows, and out of that, we have 24 columns because we have removed 11 different columns. We have removed those columns which is not required for our modeling process. Okay, so we have written the conclusion also here. You can just read out this conclusion. Where exactly we have dropped those columns. To get more clarity, I have written the entire documentation. This project file will be sharing in the Telegram group. You can just go accordingly. Okay. Now we have something called encoding and imputing techniques. So students, what is the difference between encoding and imputing? What do you mean by encoding and what do you mean by imputing? What can you answer for encoding? I think this discussion we had done in the last session as well, encoding. And we also had checked few encoding techniques as well. Okay, first we'll talk about encoding. What do you mean by encoding? What exactly is encoding? You can frame your own sentence, encoding. Okay. Okay, converting the categorical data into numerical data. Yes, correct. Okay, so what is encoding here? Converting the categorical data into the numerical data. You have to understand one thing here. Your machine learning model can never understand the alphabets, the characters, string data. No, it will not understand that. So what you have to do? You have to convert the categorical data into the numbers. to the numerical values. Okay. To do that kind of technique, we'll apply the encoding techniques. Okay. Yes, converting the categorical data to the numerical data is nothing but the encoding is. Okay, so can you just tell me what are the encoding techniques we can perform? Different encoding techniques. I think in the last session we had taken few encoding techniques. Okay, one is label encoding, good. One hot encoding, binary encoding, okay. Yes, okay. There are few encoding techniques what we had done. Yes. Okay, let's see. Now what I have done is, to apply this technique, first I'll just take all the numerical values here. Okay. So I have used the variable called numerical columns. And what I'm doing, I'm taking the entire data. From the entire data, I'm selecting the D types. Now this D types is nothing but I'm selecting specific data types. Okay. And I've used a function exclude object data. Okay. So what I've done, I'm taking the entire data set here. In the entire data set, I'm selecting the data types and I have given one condition inside that while selecting the data types, I need to exclude the object data, which means I can accept the integer values, I can accept the date values, I can accept the floating data. What I cannot accept the object data. Apart from this, entire things can be accepted. Okay. And what I have to do after that, I need to create the columns of that and I need to convert into the list. I'll be taking all the columns of that and I'm converting into the list. Now here we go. Once you do that, all the columns has been taken out. Okay. Where it is excluding the object column, object values. Okay. Now the column called vehicle age, we had the integer values. I think we had 3, 4, 5, etc. the values. Vehicle odometer value, 20,000, 30,000, this many kilometers driven. Even that column is the numerical data which is containing. Then average price, clean price. Again, all these columns are available in the numerical values only. Okay. So what I have done, simply I have taken a variable called numerical columns and all the column which is related to the numerical value I have stored in the variable called numerical columns. Okay. Now, after that, what I'll be doing, let's apply the simple imputer. Okay. Previously, we applied encoding techniques. We talked about encoding, right? We did not speak about imputing. Now, can you tell me what is imputing now? Encoding you have understood. What do you mean by imputing? Impute. Yeah, filling the missing values. You can simply tell that doing some imputation, which means filling out some values. Okay. So imputation takes with two different things. You can either impute with mean value or the median value. Okay. To apply the imputation, what I've done, I'm using one of the library that is sklearn, which means scikit-learn. Now, scikit-learn is also one of the Python library where you can get the algorithms as well inside this. Okay. And I'm using one of the technique called impute. I'm imputing simple imputer now. Okay. So let me just run this. Okay. And before applying the simple imputer, let's check all the columns now. Now, in the train data, these are the columns what I have. And these are the missing values what I have. Okay. There's a column called wheel type, which is having 3,174 missing values. And then nationality column have 5, size have 5 missing values, etc. It goes on, right? Now, out of which what I'll be doing is, I'll take a variable called imputer now. Now, in the variable called imputer, the function what I have imported, that is here, simple imputer. I'll try to put that function here. I'm using simple imputer. And what is the strategy I'm using? I'm using the strategy as mean. Okay. Now, let us have a discussion here. Can you tell me why exactly I'm using mean here for the imputing technique? What might be the reason? You can, we are just taking the average of it and we are filling it up. Okay. Now, can you just suggest me which is the best technique to be used? Whether mean is the best method or the median is the best? Okay. See, whenever you apply the imputing technique, you have to cross check two things. One is first you have to check the data set, whatever you have taken out, whether the data set is containing any of the outliers. Okay, so you have to be sure that there are no outliers. And if you have the outliers in the data set, okay, in that case, you can simply go ahead with median. Why? Because median will try to what overcome the outlier values. Okay, so there are two things what you can just do here. Directly, the first scenario is you can remove all the outliers in the data set. Then you can go ahead and apply the mean function, or else while doing the imputing, you can, if you have included few outliers, you can apply the median function. Okay, so you can choose accordingly. Okay, but as much you clean the data very good, that much the easier the model will become, and it will try to give the best thing. Yes, you can also check the skewness of the data, and you can give the imputing technique whether to use mean or median. Okay, now I've used the strategy as mean here, and after giving the strategy as mean, you can see wherever there are missing values. So these are the columns where there are missing values, right? So let's take one of the column here. Like let us take the column called clean price. There are 315 values, missing values. Now in that 315 missing values, the entire data would be taken out, the entire values in that column. Okay, it will take the average value of that specific column. Now, wherever there is missing value, that average value, what has been taken out, that will be replaced in these positions. Okay, 315 positions where we had missing values, all the mean value will be replaced. That is what I'm trying to do here. I can go ahead with mean, or I can go with median also. Okay, whenever you have outliers, you can go ahead with the median. But if you don't have any outliers, you can go ahead with the mean. Okay, let us see now. I have applied the imputer now. So in the imputer variable, I have created an imputer function where it will apply the mean strategy now. Now let us see how exactly imputer will work. Now this is the entire trend here, and I'm applying the imputing technique for the numerical columns. Okay, because there are few columns where I cannot apply the imputing technique, right? There's a column called color. Now color has a categorical data, which means white, blue, gray, those values are there. So I cannot apply mean or median for that column. If you talk about submodel, there are 8 values. Submodel in the sense Chevrolet, or Ford or something, different values are there. I cannot apply the mean for that. So what I've done, I'm applying only the mean value or imputer technique only for the numerical values. Okay, numerical columns, not numerical values, for numerical columns. Here you can see I'll just use imputer dot fit transform, which means I'm trying to fit that and I'm transforming the values now. Okay, now if you just run this and if you just check the values now, wherever we had the missing values, wherever we had uh, numerical missing values, it got replaced with the mean value. Okay, you can cross check here, all the missing values got replaced with those mean values of those specific columns. Okay, that is how we can apply the simple imputer technique. Students, understood here? Any doubt till here? Any doubts? Yes. Okay. So there are a few more things what has to be done in the pre-processing. And we have run out of time. And if we just start explaining now, I think it would become much hectic for you people as well. So the session will just do it, or we continue in the next, I think Thursday. Okay, that will be the next session. We'll continue on that day, and I'll be sharing all these materials, all these files in the Telegram group what we have created out, and you can just clarify each and everything, and you can just see the project outline how we have started, and you can create a simple structure how you can choose the problem statement, how you can just do the pre-processing, where exactly you can apply the EDA process, where exactly you can work on modeling part, or how you can split the data, each and everything you can just go ahead. Okay. And if you have any doubts also, uh, once you just execute all the code cells which is written in the project, okay, that will give you more clarity. You can also download this file and you can just keep it for your reference as well. Okay. And if you are good enough to work on the project, yes, you can start working on the project part. Okay. There are few things what we have to do it again. Okay. I think we have to, yes, we have label encoding. What we have done here, we have applied the one hot encoding as well. We'll be explaining one hot encoding in the next session. Then we have scaling down the data. Then we'll talk about training, validation, and test set. Then we'll try to create a dumb model. We'll create the different models. Like you can see here, we have created a model number one, that is logistic regression. How your logistic regression is giving the accuracy. And we're gonna check out each and everything. We'll evaluate our model by checking the confusion matrix here. Then we can go ahead with other algorithm, that is KNN classifier, how our KNN classifier is giving the output. We can go ahead with decision tree. Then after decision tree, we'll go with random forest. Okay. And then let us see which is the best model. We can just select it out. So there are quite few more techniques what we will be applying in this specific problem statement. So kindly stay tuned and understand each and everything, understand the flow, select the problem statement, start working on it. And if you are completely new to the Python programming, what you can just do is you can spend few days to understand the Python. Why? Because Python is one of the easiest language what you can learn in terms of programming. And you can start working on the project as well. Okay. So this entire materials, whatever the projects we will be doing in future also, and whatever we have done earlier, that will be posted in the Telegram group. Not only that, we'll also share the PPT template. Like other day, we had a discussion, right, in AMA session, that we'll be sharing the PPT template. We'll be sharing the PPT template in the Telegram group after this session. You can find it. And if you have completed your project, you can just start creating the presentation. Then you can go ahead with the submission as well. Okay. Not only that, we'll give few project ideas or few problem statements what you can just start working with. You can understand each and every problem statement, and you can just create your projects as well. Okay. Few projects will be given. Okay. Not entirely, like we'll be giving few project ideas where you can just look onto it. Okay. And if you want the source, like where you can collect the data, Kaggle is one of the platform where everyone feel that you can get the data set easily. Okay. Yes. Ma'am, do you have any updates, Kartika ma'am, for the students?
Yes, Tawfiq sir. Yeah. So students, one thing which I would like to mention here is, if you look at the YouTube comment or the Zoom chat, many students, you keep on asking the same questions during the session. It is not just, interrupting the other students, but also, you are just diverting the topic and the focus of other students. Please ensure if you have any questions, you can always raise it on your LMS, number one. Number two, if I say focus on the session, please do focus on the session, because you're making others to raise the same question again and again in the chat section or in the comment section. Today, there were two students, Kushi Keswani and the other one, Man or Man. I'm not very sure. So you guys kept on asking the same question again and again. So I hope your questions are answered. I have already mentioned that your questions will be answered at the end of the session. So it is answered. Okay. And if you want any information, your recordings are already available in the Telegram group. Please do go through that. Okay, because we cannot explain everything whichever has happened from the start of this internship in just a chat or in a simple comment. We cannot answer you those questions because the content is deep. Okay, so if you miss any session, the recordings are already in the group. You can go back to the group, refer to the links and understand things in a better way. If it comes to your projects, if you would like to get more information, please do not miss your AMA session. In the AMA session, I think the other students would also agree with this. In the AMA session, we discuss deeper things. Okay, about your project, about the course completion, about the problems whichever you're facing, right? Even if you do not have questions also, we would request all of you to attend the AMA session, because that will give you the answers for all your questions. Okay. Number three, those who are having issues with your MS Learn account or LMS or with the certification, anything. For the May batch students, you should not ask for any certification now because we still have time. Your attendance is pending, your project submission is pending. Still, we have more technical sessions to go, right? So definitely we still have time. You should not raise any question on the certifications now. And many students, again, they are asking for certificates. Ma'am, I have completed the courses on advanced. Again, I repeat, there are no individual certifications. There is only one certificate which we provide for the course completion is your internship certificate. Remember that. Okay, no separate certificates are issued for individual courses. Even if you complete advanced or intermediate, whatever it is, you can use the achievement screenshot as your completion proof. There is no individual certificate provided. Only the internship completion certificate is provided upon successful completion of your entire internship. That includes your attendance and project submission as well. Okay, clear all of you? So all other further informations will be shared in your Telegram group. So stay tuned with that. All clear? All of you? Can you drop clear in the chat? Man and the other person, Kushi, are you both clear with your questions? And also, you guys have been asking about the project inputs. So for project inputs, we've been giving throughout the session. If you are constantly listening to the session, you would have understood, okay, whatever inputs the trainers were giving is relevant to your projects only. Okay, the further things, they've already told you that they'll be giving you the inputs in the group, Telegram group itself. So please stay tuned with that. And today, along with the attendance link and the recording, I am also going to share the project template. So use it. The deadline to submit your project is 13th of June. Okay, so these many informations will be shared in your Telegram group further. So please stay tuned with that, and please do not disturb others during the session. Do not spam the chat also. Right? So thank you so much. Thank you, Tawfiq sir, Roida sir, and Piyush sir for the support. I hope the students, enjoyed the session very well. So see you all on Thursday. Okay, so your next session will be on Thursday. That is 29th. Okay, not 29th. Yes, 29th of May is your next session. Tomorrow there won't be any sessions. Some students you keep on asking for the attendance for yesterday also. Yesterday there wasn't any sessions. Okay. So these many updates that we wanted to share. I hope it was clear to all of you. Thank you.
Thank you, ma'am. Thank you.